Greetings everyone, my name is Tanay Pant and today I'll be speaking on web-based virtual reality. I'm really excited to be amongst you all. How many of you have tried VR, virtual reality? It's a good amount. And how many of you have tried web-based virtual reality? You would have played with it Okay. So, in this presentation, we'll be discussing virtual reality, web-based virtual reality, A-frame, faster web VR prototyping with A-frame, and finally the variety of cool stuff that can be accomplished using A-frame. Virtual reality is a technology platform that transports you to realistic, interactive, and immersive 3D environments. So it's the next platform that will change how we work, play, and communicate digitally. Yeah, that's me. I'm a TED speaker from Mozilla Foundation. I'm also an author and I've written books on Firefox OS, virtual assistants for Raspberry Pi, and my latest one is on web-based virtual reality. I'm also an internal software innovator in the field of IoT and a web developer. So let's pump up the energy in this room because I feel everybody's feeling a bit lethargic. So I'm going to ask everyone to please stand up at their places. It will just take a minute, please. So now we are going to do what I call the open web stretch, and it goes like this. So reach out for all the open source streams up there. Okay, now come down, touch your toes to reach the grassroots. Come back up and blow away the winds of change. Now you put your hands in the front and shake the money tree for fundraising. Create a good shake. Now lean left to avoid the NSA. Lean right to avoid the FSB. And then go all around to avoid both the NSA and FSB. Yeah, we are done. Thank you everyone. Please have a seat. I still remember my first experience with virtual reality, and it was in the form of roller coaster simulation, and some of you might have tried that. That application blew my mind, and that is how I got started with virtual reality. And other than game development, there are different use cases of virtual reality as well. For example, if you are an engineering student, you may use virtual reality to visualize your CAD designs in 3D. If you are an artist, you might want to use Google Tilt Brush for painting in 3D in a room scale experience. And not so long ago, Samsung did a demo in which they took a person who had acrophobia. Acrophobia is the fear of heights. And they put the VR user in a place, in a simulation where he was standing on the edge of a high-rise building. So it helped to cure people of acrophobia in a controlled and safe environment. So this shows how VR can also contribute to the development of the society. VR is being backed by some of the largest corporations of the world, like Google, Sony, Samsung, HTC, everyone wants it. And these devices, they range from a variety, they range from cheap to expensive, they range from tethered to untethered. Some of them have controllers and tracking sensors as well. HTC Vive with Steam currently offers the most compelling experiences of all, but we never know what the future might hold. So we see a lot of different devices, systems, and platforms competing with each other. Can you recognize the devices shown on the screen? We start from the top left. Google Cardboard. It's Google Daydream. Third one. Samsung Gear VR. This is Oculus Rift. Sony Nintendo, yeah. HTC Vive. Can anyone recognize the device inside? I'm just kidding. The guy is with his headphones on. The current VR ecosystems have some compelling problems, and some of them are. There are gatekeepers, and app stores and corporations control the distribution of the applications. They can autonomously block or take down content. Downloads and installs are a barrier to consumption because internet is not easily accessible everywhere in the world and it's costly. And even for creation of small business pages, the whole SDKs have to be downloaded, which are gigabytes in size, and it creates a problem to consumption. And they have a closed ecosystem. There are proprietary engines and steep learning curves. You have to learn to use the whole proprietary SDKs in order to prototype even a small application. So if we want VR to be successful, we want a platform without these 3 points of friction. And the answer to our problems is WebVR. WebVR is an open virtual reality platform with the advantages of the web. WebVR is open. Anyone can publish content online. It's just like a website. You don't need any permissions or reviews. You just put it out there and share it with your friends. And it follows the open source cultures with the open source standards. And WebVR scenes are connected with each other. You can traverse between different scenes. For example, if you have a simulation of this room, there could be a hyperlink, you can cross it and you will be teleported to other room. Just like Doctor Strange. And WebVR experiences are instant because you can just click on a link which has been shared on Twitter or Facebook by your friends, and you can have an immediate VR experience and no installs are required for that. The web that we see today is basically a subset of what the web can be if we integrate it with WebVR. And web has advantages that make it the best platform for the people. A little bit about the WebVR API. The WebVR API provides optimized rendering power to the headsets, and it provides the axis position and rotation data. The initial WebVR API was drafted by Mozilla, and it has now been adopted by the working W3C community. So, as you can see, most of the major web browsers have adopted this. Firefox, Chrome, Samsung Internet, and mobile Codify. And it's not just a specification, it has been implemented. Metaverses. Metaverses are shared, persistent, and collective virtual spaces. These are alternate digital realities where you might live, work, or play in. And these are something like Matrix in the movie Matrix. And the essential thing about metaverses is that they must be decentralized, they must be open, and they must be connected with each other. And hence, web is the best platform to fully realize the potential of these metaverses. Okay, so enough theory, where do we begin? Any of you have used 3JS? 5 people. Okay, so 3JS abstracts WebGL, 3D, and WebVR, but it can be made more accessible. Before moving on, I'd like you to show a live demo. You can open this URL, drawvr.com, on your mobiles or laptops. So this demo portrays what WebVR looks like and shows the principles of metaverses and WebVR. So I have a recorded video of this website. You can browse around the website, the virtual space, by either moving your mobile, or you can also, if you are on a laptop, you can move your field of vision using the cursor. And you can move around by, if you're on mobile, you just point to the place where you want to go to. And if you're on a laptop, you can use the WASD keypad. And as you can see, these are borders and these are essentially hyperlinks. So when I walk into them, I'm teleported to WebVR store. And you can see I can browse around. There is customer service here. There are Oculus Rift posters, different VR headsets. And if you might notice, there is a goggles sign on the bottom right of the screen. So if you have a Google Cardboard or any headset, you can touch that button and your field of vision would be split into two and it would be cardboard compatible. That's the sad truth of life. It's too hard to create web VR experiences. Why? Because there is too much boilerplate. For developing for web VR, you have huge obstacles even for doing small prototypes and experiments. And this boilerplate code needs regular updating for new versions of WebVR, 3JS, and you also have to take care of all the browser bugs. You have to take care of different components like installing VR effect, preload assets, initializing scenes, setting up cameras, lights, taking care of responsiveness, the physics of the scene. And Hello World program is actually a program which helps you to get started with a new language and implement things. Now, if I ask, would any one of you be interested in starting a Hello World program in this right now? Anyone? Okay, expected. So it would be pretty cool if we can encapsulate all of this into a single line. Introducing A-Frame. It's a declarative framework for building virtual reality experiences on the web. It was launched last December, and why A-Frame? Because it's easy for web developers to create VR content without the graphics knowledge. And it makes prototyping and experimenting with web VR and UX much more easier. And it's a perfect vehicle to kickstart the web VR ecosystem. This is how a Hello World program looks like in A-Frame. So as you can see, there's the HTML tag, there's the script tag where I've included the minified version of the A-Frame JS file. And all the things that we want to include our scene go inside the A-Scene tags. As you can see, it's just HTML, and you can start by just dropping the script tag, and there are no build steps required, no installation. And one line of HTML, which is A-Scene, handles different components like canvas, camera, render, lights, controls, render loop, WebVR, polyfill, and VR effect. For further development, we put stuff inside the A-Scene tags. Here are some of the basic 3D primitives with custom elements. As you can see, I have included a box, a cylinder, a sphere, and a plane in my scene. And you can see there are different attributes to these tags which are specific to the custom elements. For example, you will see that there is a color attribute common in all of the tags. There is a position attribute which defines the position of the object that you are placing on the scene, and it's given as X, Y, Z axis. There is the rotation, and then there are some of the unique tags, unique attributes specific to some tags. Like you have the radius and height for cylinder, you have just the radius for sphere. As you can see, A-Frame is highly readable because HTML is arguably the most accessible language in computing, and you can just copy-paste HTML from one place to another, and it will just work. Let's quickly take a look at an example of how cool it would be if someday A-Frame gets integrated with Wikipedia. So suppose you want to see an article on, say, Burj Khalifa, and you want to see what it looks like. You'll be able to open it on your phones, and just from Wikipedia, you'll be able to get experience of how the buildings and monuments actually look like. Since A-Frame is based on HTML, it is compatible with all of the existing JavaScript frameworks. And here HTML is an intermediary layer between WebGL and 3JS. Under the hood, A-Frame is just an extensible framework for 3JS. And it's compatible with D3, Vue, React, Redux, jQuery, and Angular. And if you work with data science, for example, and use D3 for your visualizations, you'd be able to mix this with A-Frame and see and visualize your data in a 3D environment. I'd request a few to do this demo. about this demo, what I've done here is I have integrated A-frame with Firebase so that every time some of you open this website, a new stick figure like this would pop up, and open the website, you'll see available figures. So about this recording, I have recorded this video using my laptop, and I had another session open using my mobile. As you can see, this is the simulation of the conference room. There's the speaker, there are the attendees, and this guy right here, it's my session, and when I tap on the screen, it raises its hands like crazy. When I put the screen down, it looks down. Do it like this, it looks up. And yeah, tapping is fun. Moving on. A-frame is an entity component framework. Have any of you used Unity? Quite some people. So, entity component system is popular in game development and is used by softwares like Unity 3D. And all objects in the scene are basically entities that are inherently empty objects. And you can plug in components to attach appearance, behavior, and functionality to these entities. The 2D web was one where everything was fixed, but the 3D VR web is different because there are objects of infinite types and complexities. And hence the entity component framework provides an easy way to build up web VR experiences. You can create your own entities using A-frame, and it starts off by the A-entity tag. By itself, it has no appearance, behavior, or functionality, and we have to attach components to it. So this is how an entity looks like when you attach components to it. As you can see, the syntax is similar to CSS. The component names are HTML attributes, and the values of the properties of these components are basically HTML's attributes value. And here are some of the examples, like I've attached behavior to it using movement pattern and animation. I've attached functionality and appearance to it using the geometry, material, position, rotation, and scale attributes. Since A-frame is basically 3JS wrapped around a nice syntax, you can create your own components as well. And this is how you can write your custom components, because A-frame has full access to the WebVR APIs and 3JS. So first of all, you have to define a schema, because the schema defines how data is passed from the HTML. And there are different lifecycle methods like init, update, remove, and tick. And if you are familiar with Android development, you might relate these to lifecycle of an application. And this is how a component is made. These are some of the components that ship with A-frame, and they are like position, rotation, hand controls for the controllers, light, materials, sound, fog, cursor. And by the way, if you are worried about having to build scale replicas of famous monuments, for example, Church on the Blood with boxes and cylinders, you can put your mind at ease, because there are some particular components like the collider model and the object model. The collider model primitive displays a 3D collider model that can be created from 3D model softwares or can be downloaded from the internet. And the object model loads a 3D model using a .object.odj file and material using a .mtl file. And since A-frame is fully extensible at its core, the community filled the ecosystem with tons of components. You can see there's a Firebase component which I used in my demo, and it has been contributed by the community members. And the component system is the lifeblood of A-frame. You can simply drop these components from one place and you can use them straight from HTML. This is an example of advanced developers empowering new developers and working on collecting these components. These components are collected and are made available in the A-Frame registry. It's like a store of components which the A-registry ensure about sell, and it's out there for everyone to use. And people can browse, search, and take the JS file and link it to their scenes. Okay, you must be thinking that it's okay that we don't have to create objects from scratch. Objects you can take in. What is that we are developing? Software like Blender, but positioning them properly according to your scene and doing that in attributes, X, Y, Z axis, that's really terrible because we have to do a lot of trial and error and it take a lot of time. So I can show you there's this feature called A-Frame Inspector, and if you are on a laptop, I'd request you to open the website aframe.io. aframe.io. So there's this demo called UI on the A-Frame website. If you have any web scene that's made using A-Frame, you can simply press Alt, Control, and I on any of your web scene, and it will invoke the A-Frame Inspector. As you can see, when once you enter the A-Frame Inspector, you can translate objects, rotate the objects, scale them, you can change brightness, intensity, color. You can add new light sources to change your perspective to see if the positioning and other works properly. Objects, change the radius, change the nature of the object. Lots of different things. So once you make sure that you are fine with how your scene looks, you can save this and all of the changes that you have made will be exported as HTML. This is really object inspector. Save it as HTML. And we have the editors. I think it looks good. I think it looks good. Along with VR, AR is also possible using A-Frame. Here is a demo that utilizes the camera APIs from the mobile, and it's combined with A-Frame, so it gives augmented reality experience. There is also a cool library called ARJS, and it's also built using 3JS, and you can integrate ARJS with A-Frame and create really beautiful experiences. And somebody recently created something similar to Pokemon Go using these technologies, and that just goes on to show how powerful this is. How many of you are familiar with what Google Tintbrush is? Google Tintbrush? Three people. So Google Tintbrush, you have the software installed on an HTC Vive. You have a room scale experience. You have sensors in the room, and you have the two controllers in your hand, and you can paint using the controllers. There you can paint using lights, you can paint using colors, and it's much fun. And to show how powerful A-Frame is, the Most VR team over at Mozilla constructed a 90 plus frame per second room scale Tintbrush experience in just a few weeks using just A-Frame. In a nutshell, VR is fun, and A-Frame makes developing VR content fun. A-Frame is an open source and inclusive project. You might have opened the website already. It's aframe.io, and most of the work is done on GitHub. There is an active community on Slack where you can share your projects, interact, hang out, seek help, and there are a lot of active developers there. And the last time I updated, there were about 1,750 members on Slack, which is bigger than what the Web VR API community currently has. So this goes on to show how widely it has been adopted by the people. And there are featured projects. You can, if you have developed something awesome using A-Frame, you can submit in a pull request to the awesome A-Frame repository on GitHub, and you can get featured on a week of A-Frame blog. And don't forget to visit the website. I conclude my session now. Thank you. Any questions?
Thank you. I've got a question. I have seen the A-Frame editor that you presented, and it kind of reminds me of something I already saw. I saw an editor based on 3JS. You could change the things that you showed us in this demo, and you could also save it as HTML and JS file. So, is this A-Frame editor based on that one that I saw, or is it a different stuff?
I think I get which website you are talking about, although I don't remember the name, but no, it's not based on that. And that editor allows you to connect different things with each other, and it's just an editor. And A-Frame is a full framework, and its components are based on its principles, and it's different than that. Did that answer the question?
Kind of. Okay, thank you. Thank you very much.
Thank you for your presentation. It was awesome. React community have their own framework for VR called React VR. So, do you see that framework as a concurrency framework for VR or not?
Concurrency framework for VR?
Yeah, for A-Frame. Because under the hood, React VR also uses F3JS.
So, this, what I would like to say is that A-Frame is pretty much bleeding edge at this moment, and the roadmap is it's evolving with each day. And as if we compare about React VR and A-Frame, it's more about usability. And if you are a beginner, A-Frame is much easy to good React VR.
Sorry, could you speak a little bit louder?
Okay. So I was saying that the A-Frame framework is really bleeding edge, and it's evolving really quickly. I mean, even the data itself was probably introduced 3 or 4 months ago. And if you compare it to React VR, I can say I've tried React VR much, yes, I've tried it, and it's more about the usability. If we talk from web developers' perspective, it's much more easier to implement, and you can create small demos in a less amount of time using it.
Sorry, could I ask one question? We already have some gaming APIs like controller API in browser. Also, we already have a WebAssembly. What's next in gaming and VR technologies will be next? I mean, well, which next technology do you see?
In VR itself? In VR, web VR?
Okay.
No, I'm asking.
Not about only VR, but something else maybe. Because I see the VR main area is gaming. So, what's next in that area?
That area is in gaming. So I think before moving on to new technologies, there should be substantial improvement in the devices itself, because software in VR and web VR is evolving pretty quickly, but there are still troubles. If there's a lag in rendering, you get motion sickness in VR. So I think hardware should be next thing, because that really needs to keep up with the software.
Thank you for your presentation. Are there instruments, for example, to convert videos are the instruments to convert video stream to this model?
Video streams to models?
Yes.
No, I mean, you can have a 360 video, but they are not exactly models. Videos have different component tags for them, and models are mostly used for solid objects like, say, a chair or a building. And videos are defined as different components of it.
Any more questions?
Hello. We a software company. We present here on Pant. You can see our version of realistic virtual reality. But we use about 200 compute shaders to do ray tracing. Do you know when this kind of shaders will be available in web browsers?
I think that it's evolving pretty quickly because recently a new version of WebGL rolled out, and that has really high performance indexes. So yeah, I mean, if we talk about performance, you might have seen the example of a painter which was 90 plus frames per second, and even if you have old handsets, you can, like 2 years old, you can get it working on 60 plus frames per second. But yeah, if we have heavy shaders and proper tracing for that, it gets really expensive for browsing. So it mostly depends upon the underlying technology platform on which it runs, which is the WebGL. So yeah, there's no time for that. Performance of media is better sometimes. It depends on the use case.
Do you plan to include the full functionality of video cards in this standard in the web VR?
So I'm not pretty sure about that, but I can get back to you on that.
Похоже, все. Поблагодарим.